Welcome to Ymt218 Object-Oriented Programming, and we are still addressing Chapter 10, Classes and Object-Oriented Programming. This is the third and final part of it. Previously, we studied topics related to the difference between procedural-oriented and object-oriented. We discussed the essence of a class and object, the instantiation, and so on. So how to create also a basic class, and the idea of creating a skeleton which we refer to by a class, and then instantiating it, creating objects out of it, and so on. So today we will carry on the same scenario. We will just discuss special topics related to the same chapter. So we will go through hiding attributes, storing classes in modules, working with instances, accessors and mutators, techniques for designing classes. So we will cover those in essentially basic sense. Before going to the practical, we will have separate practical sessions, so we will not actually have any hands-on while addressing these topics. We will not go to practical. Okay. We discussed the idea of protecting our private data or whatever the attributes of a class while creating classes or while dealing with object-oriented, and we said that it is you can say a favorable or an advantage when we protect our data from intended or unintended alteration. However, the code we discussed yesterday about creating, not yesterday, the last session, I'm sorry, the creating a coin, for example, tossing a coin. When we created that coin, the class, we didn't actually set the private data or the attribute as private. So we kept it actually by default, and the default is not private. So let me remind you, I'll just take you directly to that program, or that actually code or class. So we presented this one in the slide, and we mentioned about all these details. And remember that we have only one attribute here, side up. We said that the coin, in this case, we care only, or we are concerned only with the face or the side of the coin, so which side is up. And in that case, side up is actually the attribute, the only attribute that we have. The problem with this attribute now is it is not private. So if I try to access to it, coin.sideUp, I will get its own data, or I can alter it. Now, for example, I'm doing this, setting up the side up from another method, from a method somewhere, the main maybe, or another method. It's out of the class for sure. And then I printed out the side up, and it will turn out heads. You can try it yourselves. So the idea is like this: how can we do such a thing? How is it possible? Why? Because side up is not private in this case, and we can access to it using the object here. Let me run this code, and we see. Look at this. So I set up the side myself, and the outcome is heads, and this is not a good outcome. We don't want usually other methods to manipulate our data or change the attributes of a class. In order for us to avoid such a thing, we set the private data, the attribute to private, and this is a common attitude. How do we do it? We need to add double underscores right in front of the attribute. And wherever you use the attribute, you have to add here and here, and everywhere you use this attribute. So now it is private in this case. I'll keep this one the way it is. I created another sketch for this purpose. Now look, this is private, and this one is private in this case. So once we created private, we can use it the way it is, and it is set private. You cannot access to it from outside. So if you try to do this, it won't work. So if you're lucky by chance, just by based on the probability, you will get heads, but it wouldn't change the fact that side up if you try to do so. If you try to access to the side up, sorry, it wouldn't work in that case. Let's just try. I'm sorry. Now I said most likely it's by chance. Let's just rerun and see. Okay. Heads, maybe if we run again, let me just try tails. Now you see. Because this is based on probability, you may say, why do you keep repeating? I keep repeating for this specific reason. Now remember that the last one is tails, okay? Just remember it. Now we are tossing a coin. So exactly we're simulating the real behavior of a coin. When you toss it, you will not know for sure which side is up, heads or tails, until you see it. So this is what happens to us exactly now. I don't know which side will be up after tossing until I toss. So the problem is, I said, okay, I toss here, and whatever comes out, I change it, and then I see the outcome. So I claim that I'm making it heads, and I'm just printing the outcome. In this case, it wouldn't work. Why? Because it's set private, it wouldn't change it. So simply this is the idea. If you call the get side up, or if you call toss again here, it would actually work in a better way for sure. Okay, so let's say I cheat, I try to set up the side up heads, and then I toss and see how things go. Well, in that case it wouldn't work, because we already had a toss here. If you change it, this is private, it wouldn't work. And in that case, if you toss again, of course it will change. But in brief, in basic sense, what I'm saying is, if you set it to private, you cannot access to it except with these methods here. These will be permitted to access to the private attribute, and that is very convenient, especially with many applications in software development. Okay, let's get back to our slides. Right, how can we store classes in modules? Sometimes you create a class and you spend your time just developing it and you like it. It's convenient for your work. You may save it by its name.py, lowercase, as an extension. Then if you need to use it in future, you can call it the way you call modules. Exactly, you import it. So you import it and then you can use it exactly the way we used modules before. If you remember, when we started writing functions, we created also our own module. We saved it in .py file, and then we call it, or we called it that time when we needed it. Now we can call it whenever we create our own customized class and save it. We can call it whenever we need it if we save it as a module. The same idea. All right. What we explained so far didn't address two main issues. The first one is passing an argument to the instructor of to the initializer of a class in Python. This is one of the things that we didn't address. The other one is addressing or speaking about str method, a special method for just string return the status of the object. So we will speak about those in this session, or in this you can say program. Now, instead of showing you in the slide here, I can go directly to the program and discuss another program I wrote for you. It's easier. You can have that example as just a practice for you in the slide. I'll explain to you about car. Car could be a class. Why? It's an object, represents actually different attributes, and you may think of different things represented by cars so that you can address them in a class. For example, speed is one of the attributes that we have in cars, right? You may think about many attributes. It's just one of the attributes that we may think. Now assume that I want to either print out the speed, or increase the speed, accelerate the car, or brake, slow down the car. So what I'm going to do, I create a class by the name of car, and then I use the initializer, and I receive self the reference to the object that we create. I'm sorry, here, my car. And then I pass speed also. Why? Because I'm concerned with speed as you can say attribute in this case. So I create my speed here. It can be the same name or a different name, it doesn't matter, but this is a private attribute. This is just a parameter, okay? So pay attention. This is a parameter assigned to a private attribute. We can have a function for acceleration, just speeding up. It could be of any value, speeding up or slowing down. Also another function, getting the speed, and one more function for getting the state of the object. So the state of the object means what in this case? This str. Str is very similar to the initializer, but in another sense. It's a special case of function, and it's restricted only to one thing, returning a string. You can return a string, and this string should represent actually the attribute that you have. Not all of them, but at least my object. What's the status of my object right now? So I create an object, give me the brief info about it. If a student, maybe you can return name, surname, maybe GPA, things like that. But in this case, for the car, we are concerned about speed, so we can return the speed, like the car is moving at speed of, we return the speed. So this is a string, remember that, you have to return a string. Now I'm casting this self.speed. Why? Because I'm casting it to string. Why? Because it's actually numerical in this case, and we are not interested in returning numerical value. It's rather a string, and that's why we are connecting a string, concatenating the string with this one. So this is the idea. If you create such a class where you are supposed to send or to pass an argument, then you need to add this argument or the parameter to the argument list here. Self is, as we said before, is by default, so you don't send anything. It comes once you instantiate, it comes by itself. It's automatically done. You don't interfere with it. But if you have any other parameter to be passed, not only one, you may pass others. We are just concerned with the speed. Then you have to include it, self comma the argument that you're going to pass. So we have a parameter for the argument to be passed here, speed. Let's say we are addressing another argument, comma another. So that is usually the case. Let's say we have a class for a student. We need to receive the name, maybe enrollment number, and maybe GPA. So we will have self, then name, then enrollment number, then GPA. So we will have a list of 4 actually arguments, self by default, and then 3 extra. So this is the idea. The same goes to all these functions here. If you need any argument while calling the function or while dealing with this function, you need to pass it. And we will see in practical how we do that, okay? I hope it's clear. Let's get back to our slides. All right, so as I said, this one, keep it to you. It's very similar. It's very similar to the car example. I don't want to go through it in details as we are just in the theoretical session. So this is a private, as we explained, and we have an argument to be passed. So we have a parameter next to self, and it applies similar to other details that we just explained. I explained about the string. str method is convenient. Why? Because from time to time we need to see the status of our object. So in that case you can just print the str, whatever it will return to you in that case. Okay. Instances. Now I have created a class. How many instances can I have? You can have, as I said before, I mentioned this one before, as many instances as you like or as your problem requires. So in that case, you may create different instances, and these instances you may customize their attributes. Not necessarily that they all match with one attribute. And just a simple example, if we create a class by the name of student, you don't expect all the objects from this class student will have the same name. Not all students do have the same name, or it's impossible for students to have the same enrollment number. So that's why the attributes will be customized based on the instances themselves that we create. Okay, you may think about coin also, because we spoke about it. If you create 3 objects, they will have different attributes and they will change based on the application, and that's fine. There will be no problem. It depends on your own implementation of the problem. Accessors and mutators, or actually what we refer to by getters and setters. Accessors are methods that allow you to access to private data and receive their values or whatever they have without changing them. So these are accessors. Sometimes we call them getters. Now, just remember this. We explained earlier about it. For example, like this, def get balance. This is an accessor. It returns the balance. Or for example, let me show you from this one. Yeah, look at this, get speed. For this one is a special case, okay? And how, well, I forgot to tell you how to print this one. For example, you say, okay, we created a special str method. How do I get the return of it? You need to print the instance itself. Now we created an instance, my car. If you want to get the status, just print my car. This will automatically return to you, when you print here, the content of the return. So this string. So what will be appeared here, the string available in here. Let me just run and show you. Now look, the last line. The car is moving at speed of 30, and this is exactly what we are looking for, and this is what the return statement. So you just print the instantiated object, and in that case you will get its speed. If you have different objects, you can print them as long as you provide the proper str method and function in this case. Okay, so let's get back. We explain about this. So these are the getters. So we get values from the private attributes through functions or methods. And in that case, how about if I want to change a value of a private attribute? We said that we are not supposed to alter it from a main method or any other method or a function. So what we are supposed to do is we need to create a method that belongs to a class, to the class itself, and then that method will allow us to change or alter the value or set the value of a private attribute. And that, for that reason, since we say it is setting up the value, we call it mutator or setter. So accessor or getter, and mutator or setter. So the mutator, actually any method that changes a private attribute, okay, or maybe sets up its value, not necessarily that we change it, maybe it has no value at all, it's not been initialized, so I can initialize it using a mutator. However, in Python, if you use the initializer and set up the values of your private data, you already have some maybe initial or default values, and for that reason I keep saying like changing the values. All right. Can we pass an object as an argument? Yes, with no problem. We have already gone through this before. We passed lists, we passed dictionaries and things to functions with no problem. You can pass also an object to a function, and then you deal with it exactly as an object. So if you want to access to any of its methods, you need to use object name dot method name, and that's exactly the way we deal with objects. So if it is passed to as an argument to another method, from one method to another method, there is no problem. You just need to deal with it the way it is. You can assign its reference to another variable name. It's not necessarily the same name. We discussed this before about passing the reference to a variable name, but that's not the main idea. how we deal with the argument, which is an object, is just exactly the way we deal with it in normal functions like main or any other somewhere else. Okay. How can we represent a class by UML? You guys are familiar with UML, Unified Modeling Language, and it's quite familiar with those who work in software, industry, or development. You studied this before in algorithm and programming, but we will revise it or actually brush it up while discussing Python topics. Now, again, the top section is actually in the unified modeling language. Before I go to the top section, we represent a class, any class, by you can say a rectangle, and this rectangle has three main sections. The top section is actually for the name of the class, and the section next to it for the list of attributes, the private attributes, okay, and not necessarily private, but the attributes in general. Then next to that, at the bottom, we have the methods. So we have the list of all methods that we have. So here we have this division, the top side for the class name, then we have the section for attributes, and then we have the methods. Like this, for example, if we are speaking about coin, the class that we just created, we have the name of the class, and then next to it we have side up, and you write it the way it is, if it is private or not. If it is not private, you have to eliminate these underscores, and next to that you need to list all the methods. Now if there is an argument list, let's say if we speak about car earlier, there was an argument to be sent, so we have a parameter included. So we had self, and then we had comma speed. So here you should provide speed. Here if you have another method, you need to provide speed if it is receiving it. If not, self, do not put it because it's by default. But if you have any other argument to be sent or list of arguments, include them. Okay. How can we actually define, or how can we identify or find the class that we are looking for in a problem? It's not an easy and straightforward task. Usually it comes by practice, but there are steps that may help you at the beginning, just to you can say, to put your foot on the way, to start to help you start up creating classes, especially with like object oriented. Now the first thing is you need to have a description about the problem. It may be a question given to you, the description, or it may be written by some expert, or maybe yourself you can write it if you know how to articulate the problem. Then after that, you need to identify all the nouns. Whatever noun is available, also pronouns, all these you need to identify them, and then you need to refine the list. How do you do it? It sounds not exactly clear. Now think about this. Let's say if you are looking for writing, let's say a class to help in printing a code for a service, a car service, for example, you need to think about any physical object, okay, that simulates the program. Whatever the role played by a person, maybe the result of a business event, whatever. So think about it. Like, let's say this example, a description of how, let's say we give a name of a shop, maybe Joe's automotive shop. So let's say this is a description of how their shop will print the codes to the customers. So in that case, this description, either you write it by yourself if you thoroughly understand the problem, if you have a clear understanding of the problem. So if you have a clear understanding of the problem, you can write it, or maybe the one who is actually running that shop can write it for you, in order for you to create a class for the service or whatever, printing out the codes for customers. Now let's just address the available text here. How many names do we have? So many, right? I don't want to read the whole text, but you have to list them all, and then you try to refine. How do we list them? Now this is the exact idea. You need to include, for example, Joe's automotive shop, and then foreign cars, then for example, cars again, so you don't repeat it, Mercedes, also Porsche, also BMW, so you need to list them all. Names, nouns, pronouns, also noun phrases, you need to include them all. So how many of those are available? So many. So in that case, you need to highlight them, as I said. So you need to highlight all these names. Now you may think, well, it is too long. How can I address all of them? You don't have to waste your time, because it's easy actually to eliminate a lot of them. You just need to list them, list all these names and nouns and pronouns and noun phrases, then start eliminating them. How can we? So we need to refine. Refine means what? We need to remove all the repeated names and names that represent the same thing, okay? We need to remove also names that, or nouns that actually not of our concern. We are not concerned with their presence in our problem. Also, we need to remove the nouns that, or the nouns or noun phrases that actually represent objects, not classes. Now I'll explain to you how and give you examples. And also we need to remove nouns that represent actually simple values, like variables can be represented by variables, not a class or an object of a class. Now think about these. Address is fine, there is no problem with it. BMW, I'll tell you about it, how it can be eliminated. But car and cars can be eliminated. Why? Car and cars represent the same thing. So we don't have plural here. It doesn't matter much, because we don't say actually a class cars, we just say a class car, which can be generalized later on. Foreign cars also represent the same thing to cars. Well, if you are discussing shop, for example, and Joe's automotive shop, same. So you don't have to go very specific. Shop is enough. So sometimes this refine needs also like you to pay more attention about the responsibility of your class and what's supposed to hold as private data, what's supposed to operate on, what is it supposed to operate on this private data, and so on. But let me just come back to these points for refining. Let me show you how we can also refine. So we mentioned about foreign cars, we mentioned about the Joe's automotive shop and so on. Now think about BMW. Is it a class? Well, it can be a class, but for our problem now, we are not concerned with BMW as a specific class. It's an object rather than a class. It's an object of a class. Maybe a car BMW can be an object of car, right? So think about it. This is one of these. Mercedes also, Porsche also. So we can eliminate those, which are objects, okay? Manager also can represent something that we are not exactly interested in at the moment, okay? Now, if you think of this way, how about estimated labor charges? This is a variable. Well, the same goes to estimated parts charges. This is also a variable. Telephone number, it could be a variable. Sales tax, service code, total estimated charges year, all these can be service code, I'm sorry, service code is exactly our concern. Sales tax, the year also, the year of the whatever, the date, or maybe the date and time, maybe. These can be of variables, so we can eliminate them. What will remain? Customer, yeah, we cannot, because this represents actually a class. Car also represents a class. Service code also represents a class. Sorry, earlier I said service code. No, service code is not a variable. This is exactly our concern. We need to print it out. So this is the idea. Now, when I came up with these three, now I narrowed down the list to only three possibilities: car, customer, service. We can have three classes. It depends. So if you are concerned with things related to customers, their details only, you can write a class for customer. If you are interested in cars and customers, you can write a class for car and customer. If you are interested in the three of them, you create a class for the three of them. Now, this is what I said earlier. Let me jump and get back to it. Let's say you defined already your classes, you narrowed down the list, you get to the proper classes that you are supposed to create. How can you create it? You need to define the private attributes of the class, okay? So actually, this can be can be found or can be achieved by what? By exactly describing the what your class is supposed to know actually, or is supposed to define for you. A car, so if you are speaking about a car, what kind of knowledge you should get when you speak about car as a class? Well, you may think about the make and the model, maybe car brand. So these are basic knowledge of the car that you are speaking about. So what do you want to do with the name, model, make, whatever? You need to operate anything on them. So whatever you want to operate on these attributes, this could be the public methods or the methods that you are going to do with your class to operate on your private data. So the action to be taken by the class. So this is exactly how we articulate and create the class, and these are the proper steps as a beginner you should think of prior to taking a step in writing or creating a class. Should you stick to these points literally? No, you don't have to, but these are like scientific points that help you to do you can say a good job in deducing the idea of classes and creating proper classes. And it would be great if you start up with them until you get the proper experience to allow you to go straight away without going through these formulated, you can say, steps. This is the end of the chapter, and we will have sessions for the practical soon enough. Until then, have a good time. Goodbye.